must be a square matrix in order for an identity matrix to make sense. Okay. An inverse matrix. Now I'm going to ask you to think about where have you heard the word inverse before in here? Opposite. Okay, that's definitely true. Inverse does imply opposite. Opposite. Where else have we heard inverse? Oh, I know you heard it in your Algebra 1 class because I teach it in Algebra 1.
Inverse variation.
Okay, inverse variation. We saw that earlier. Inverse variation. Not really going with inverse variation at this point, though.
I remember the term inverse proportion.
Inversely proportional is like inverse is similar to inverse relationship. That's similar but not quite where I'm headed with this. Has anyone ever heard of a multiplicative inverse? Does anyone, it says, if those of you that have, what's another word for a multiplicative inverse? Okay. It starts with an R. Okay, so for multiplying whole numbers, that's like the reciprocal. What happens when you multiply a number by its reciprocal? It turns into 1. You get the identity out when you multiply something by its inverse. Okay? An inverse matrix, again, just like an identity, only makes sense if it's square. So if if a matrix is square, if a matrix is square, meaning it has the same number of rows as columns, then its identity is the matrix that when you multiply it to the original, leaves you with the identity, leaves you with this special matrix. So it's a matrix. If a matrix is square, its identity, or its inverse, its inverse is the matrix that when multiplied to the original gives you the identity matrix. To solve this matrix equation, first find the inverse of the matrix on the left. Let's find the matrix of this 2 by 2. Second, multiply, and let me be even more specific, since we know that matrix multiplication is not commutative. You can't just multiply in any order. We're going to left multiply each side by the inverse. All I've done is taken these two equations and made some matrices out of it. I've taken all the coefficients and made myself a coefficient matrix. -2, 3, 5, and 1. -2, 3, 5, and 1. I've taken out the variables and made them into its own little variable matrix. A 2 by 1, since there's 2 variables. And those will be equal to this little 2 by 1 of the solutions, or the constants. -11 and 19. Now why in the heck is that useful? What could you do now, knowing what we did above, to solve this equation rather rapidly? Lizzie?
Can you times it by the inverse to get that?
Why don't you use find the inverse of this matrix, left multiply it to this matrix, and you'll be left with one that tells you what x and y are. You'll be left with a 2 by 1 that tells you in the top column what x is, what the bottom column what y is.
That's pretty easy.
Find its inverse and multiply, left multiply each side by it.
It's pretty neat.
It is very neat. Nate, what's your question?
Yes,
That's very good.
so to set up that first matrix that you did,
Yep.
do you want to make sure that you have like the x's in the equations up top, make sure you have the x's over x and y?